Hello, this is Mr. Rupp, and we're studying pre-algebra section 7-1. We're going to talk about circumference and the area of circles. And there's a lot of moving parts to this section of math, but it's not that difficult. We'll run you through each individual piece and how it relates to each other. Okay? So the first thing we need to do is get some terminology, some vocabulary out of the way. So what we're going to look at is this: the circumference and area of circles, the vocabulary. So the first thing that we want to talk about is what is a circle. All right, there is a mathematical definition of it, and there it is. A circle is a set of points that are all the same distance from a center point. All right, now I haven't drawn the center point in this circle, but pretend it's there. That circle, the black line, is all the points that are the same distance from that center. Okay. All right, so what's the next piece? A radius. A radius is a line that goes from that center point to any point on the circle. Okay, anywhere along that circle's edge is, from the center to that circle's edge, is the radius. That's usually denoted by a little r right there. Okay, following on to that then is what we have, what we would call the diameter. All right, and a diameter is a line that goes from one edge of the circle to the other edge of the circle and passes directly through that center point. Okay, now if you notice, you can draw lines through that circle all over the place, and lots of them will go right through that center point from one end to the other. They are all the diameter. Okay, and if you'll look, from the center point to the edge of the circle is called the radius, but a diameter goes from the edge of the circle through the center to the other edge. So in other words, there's two radiuses, and they call them radii. Two radiuses in one diameter. Diameter is usually denoted with that little d. Okay. All right, what's next? A chord. All right, a chord is simply a line segment that goes from one end of the circle to the other. In other words, both ends of the chord of the line segment need to be on the circle. So you can draw an infinite number of chords within a circle. If you'll notice, a diameter is technically a chord because both ends of the line are on the circle. It just so happens that for a diameter, it goes to that center point. All right, what's the last piece here? The circumference. The circumference is simply the outside distance around a circle. If you started at one point on that circle and you marched your way all the way around that circle to where you started from, that's the circumference. Okay? In geometric terms other than circles, like squares and rectangles, that's called the perimeter. Same idea. It's the distance around the outside of the object. The circumference is the distance around the outside of the circle. Okay? All right. Over here, we have a guy. This guy right here. Okay? And his name is Archimedes. Archimedes of Syracuse. And way back in not so great the dawn of time, about 250 BC. Okay, Archimedes, who was the greatest mathematician of that age, he was working on what pi was. All right? And no, it was not cherry pie or anything else. What it was this value. All right, and there's a lot of other digits that we could go on. What is pi? Well, what Archimedes was discovering was that if you took the circumference of a circle, and circumference is usually denoted with a capital C, all right, and you divided that by its diameter, you ended up with the same number, no matter what size the circle, and what its circumference was. It always came down to the same number, the same ratio. Okay? And so it wasn't actually until the 18th century that we started calling it pi. Archimedes tagged this to the Greek letter that stood for p, because what he was talking about was the perimeter of a circle. All right, so this letter, this symbol, stands for p in the Greek alphabet. And then we came along and said, well, it's pi. That's what we call it. So there are a couple of distinctions here, a couple of things you need to pay attention to, all right? So pi, the circumference divided by the diameter is equal to pi, all right? Pi is an irrational number. It has no end. It has no finite discrete value. Now we can approximate it using a bunch of different ways, 3.14, 22/7, that kind of thing. But those are approximations. Those are guesses, estimates. They are not the value, the equal value of pi. Okay? So the only way that you can ever write an equal sign is if you leave pi in its symbol form. As soon as you take pi out of the symbol form and make it a number, you have to use approximation. You have to use an approximately equal sign. So here's an example, okay? If we take the circumference and we solve for the circumference right here, okay, then that means that C is equal to pi times the diameter, okay? That is equal to, because pi is still in symbolic form. Now, we can say that the circumference is actually approximately equal to 3.14 times the diameter. These wavy lines right here are the approximately equal to symbol, okay? So remember that. It's a temptation. I fall into it myself a lot of times. You know, you just get to writing C is equal to 3.14 times da-da-da-da, and then that's the answer. All right, just be aware that that's not the answer. That's an approximation of the answer. Let us move on. So scrolling down, that brings us to the circumference of a circle here. And a key concept. Yay, key concepts. We love them. All right. The circumference C, remember circumference is usually denoted by a capital C. The circumference C of a circle is equal to its diameter d times pi. All right. So there's a couple of things over here. What's the diameter equal to in terms of radius? Well, here's the d. The d goes through the whole thing, and there are two radiuses for every d. So d is equal to 2 times r. And then if you solve for r, okay, you divide by 2, then you can also say that r is equal to d over 2. So a radius is half of a diameter, and a diameter is 2 radiuses. All right? It's not that difficult. Now you just throw pi into the mix. So let's do the first example. And this example says find the circumference of this circle. Okay? So here's another thing. When they give you a line that goes all the way through and they give you one number, or they just put like a D here, then that means the whole thing. If they were talking about the radius, they would put the R or the measurement right on the line in that half that they're talking about. But in this case, since it's right on the middle, then they mean the whole thing. So the diameter, the D, is equal to 9 inches. And they want to find the circumference. Circumference is capital C. Okay, and from our set of formulas up here, since we have the diameter, then we can say that it's equal to pi d. So C is approximately equal to 3.14 times 9. All right, so C is approximately equal to, and let's whip out our calculator, and we go 3.14, 9 times. So 28.26. 28.26 0.26, and it was originally in inches. Okay, so the distance around this circle right here, the circumference, is approximately equal to 28.26 inches. Okay. All right, so let's do this second example right here. And this again says, find the circumference. The circumference is equal to, well, in this case, what do we have? We don't have the diameter anymore. What do we have here? This is called the radius. Yay! So R is equal to 7.2 centimeters. So the circumference, if we go over here and we notice that in terms of radius, then C is equal to 2 pi times the radius. Okay? So we have 2 pi R. And since we have the R here, we'll say 2 times pi times 7.2 centimeters. All right. Well, all it is here is just plugging it into your calculator and cranking it out. 2 times 3.14 times 7.2, and that's all in centimeters. So C is approximately equal to 45.216. So it's approximately equal to 45.216 centimeters. Now, you only have one digit after the decimal point, so that's where you should round to, all right? So then C would be approximately equal to 45 point, well, we want to round to here, so we look at this digit right there, the 1. And the 1 is 4 or less, so the 2 stays the same. So it's approximately equal to 45.2 centimeters. All right, moving on. So we've dealt with circumference and radiuses and diameters. Now what we're going to calculate is the area of a circle. Okay, and the area of a circle, as it brings us to this key concept here, and it says the area A is typically denoted as the area of a circle. That's the variable. And it's equal to pi times the square of the radius. Okay. Down here on example 3, it says find the area of this circle right here. So the area is equal to pi r squared. Remember, r is what we use for radius. And in this case, r is equal to 8 kilometers. So we have area, and we just drop that right in. Pi, which is 3.14, times 8 kilometers squared. All right, so the area is equal to, so let's fire up our handy dandy calculator again. And what we're going to do is 3.14, and then we're going to enter in 8. So 8 squared is 64. And 64 times 3.14 gives us 200.96. So we have 200.96. Kilometers were also in that. So kilometers comes out kilometers squared. Well, what they do is they demonstrate the exact answer and the approximate answer. Okay, so the exact answer here, the area, is 64 times pi. Okay, kilometers squared. That's the exact answer. Why? Because pi is still in symbolic form. Well, once you take pi and put it into 3.14, okay, then this is going to be approximately equal to 201 square kilometers. Now, the book will say 201.1, and I believe that's a typo because if you round this correctly, it's 201. All right, so that is the two answers for this. All right, so let's do this one. Go ahead and pause the video and see if you can work out what the area is of this circle, okay? All right, we're back. I hope you paused it, gave it a try yourself, okay? Let's get our black pen color back here. So what's the first thing that we notice about this circle? What do we know about it? What we know is we have a diameter. Okay, the 15 feet comes right in the middle of this, and it goes from one end of the edge of the circle to the other. So that's the diameter. So the diameter D is 15 feet. The area of a circle is pi r squared. So do we have an r? Well, we don't have one shown here explicitly. Okay, but what does r equal? R is equal to D over 2. Okay, remember that if you look at this picture, there are two radiuses here, from the center out to one side and from the center out to the other. Well, you just want to know what one of them is. So then that means that the D is equal to 2r. And if you want to solve for r, then you divide both sides by 2. Okay, and that gives you r is equal to D over 2. So r is equal to D over 2. And area is pi r squared. So we're going to write this out here in a couple of steps. Pi r is what? Well, D over 2 is 15 over 2 feet. And that's going to be squared. So we'll work that out a little bit nicer. Pi times 7.5 feet squared. All right, well, just to take things a step at a time, what's 7.5 squared? Well, we have 7.5. That would be 56.25. All right, so the area is pi times 56.25 feet squared. That's the exact answer. That's why there's an equal sign here. So what would the approximate value be? Well, A is equal to, or is approximately equal to 3.14 times 56.25 feet squared. All right, and that equals 176.625. So we have 176.625 feet squared. Now you'll notice I don't round any of this until I get to the very end of the problem. And that's how you work this if you want to have correct answers. Don't round in the middle of the problem. Round at the very end, keep as many decimal digits as you can, and round it at the end. Okay, so A is approximately equal to 176, and they say round to the nearest tenth. So 6 is the tenth, 2 is what we look at, so it would be 176.6 feet squared. So this is the exact answer, and this is the approximate answer. Okay? So it's not too difficult. Now, I believe that the book is using the full value of pi, which is why their answers are going to be just a touch different than the ones that I've calculated here. That's not an issue. All right? They're using the pi button. They also told you to use 3.14. I've told you to use 3.14. So use 3.14, okay? If the answers are just a little bit different than the answer key, don't sweat it. But by a little bit different, I mean like a tenth or a hundredth, okay? Not like by 15 or 20. If you get answers that different, you've done something wrong. Okay, moving on. We have a real-world example now. And all that means really is just that instead of a made-up answer, our made-up question, we're using something that actually exists. All right, so state parks. Suppose you walk around the edge of this circular Point State Park fountain. All right, an estimated circumference to be 470 feet. So based on your estimate here, what's the approximate diameter of the fountain? Okay, now obviously it's going to be a lot easier to walk around the fountain to get the circumference than it would be to pick a point, get up on the edge, plunge into the fountain, and trudge your way right across the middle of it. Not as easy to do. Much nicer and better to go around the outside. Okay, God knows what's been in that fountain. You don't want to be crawling around in there. Okay, so we know that the circumference of a circle is equal to pi times its diameter. They want to know what the diameter is based on a circumference of 470 feet. Okay, so the circumference is equal to 470 feet. So they want to know what d is. Now, there's two different ways you can solve this problem, all right? And either one works okay. I'll give you the first method first, okay? We know what c is, so let's just drop that into this equation. 470 is equal to pi times d. All right, we know we want to find d, and pi is 3.14. Okay, so we divide both sides by 3.14. Okay, and that gives us d is approximately equal to, it was approximately equal to 149 feet. Okay, well, that's one way. Now, the preferred way to do this, okay, is to take your formula, c is equal to pi d, and manipulate your formula until you have what you want to solve for, okay? So in this case, they want to know what the approximate diameter of the fountain is. So they want to know what d is here. So in order to find d, you divide both sides. You divide both sides by pi, okay? And then that gives you d is equal to the circumference divided by pi. All right, so we know that our circumference was 470 feet, and we know that pi's approximation is 3.14. Well, if you notice, it's the same thing we get over here, 470 divided by 3.14. You're not going to get a different answer, okay? Okay, I have a bonus question, and this is it. Okay, the wheels on a truck go round and round, round and round, round and round. Okay, the wheels on the truck have a radius of 18 inches. How far will the truck have traveled after the wheels have made exactly 150 revolutions? Okay. Email me your answer, your solution, through regular email. Thank you very much. All right. So that's it for this section. Thank you for watching. Please like it or comment on it if you want. And I will see you next time, okay?